Introduction to Functions, Part 2. Use function notation to describe a function. Evaluate functions algebraically from a table and from a graph. We'll solve functions, and we'll evaluate a difference quotient. And we're going to do this in 2 parts. First, suppose a worker makes $10 per hour and works at most 5 hours per day. The table shows some possible values for the worker's daily salary. Explain why this relation is a function. So remember, our definition of function is a relation in which every input value, every x value, is associated with exactly one y value. And if we look here at the table, we can see that every input has exactly one output. If the worker knows how many hours they worked, there's only one salary that's generated. Find the domain and range of this function. So remember, the domain is a set of all the input values, or all the first coordinates of the relation. And so the domain in this case would be the set of numbers 0, 1, 2, 3, 4, and 5. The range is a set of second coordinates. And so the range, our output values, would be 0, 10, 20, 30, 40, and 50. Represent this function using function notation. Whenever we're talking about functions, we use a letter to describe them or to name them. So I'm just going to call this function f. And then in parentheses, we have a variable that describes the input values. And I'm just going to call it x. And so in this function, which I've called function f, so this is just the name of the function here. And when we say that out loud, we say it f of x. So we have function f, or in other words, f of x. And the salary function, we take every input value x and multiply it by 10. And so in function notation, we could write f of x equals 10x, or in other words, f of x equals 10 times x. Evaluating solving functions algebraically. Evaluating functions at specific values. So given the function f of x is equal to 3x squared plus 2x minus 1, find f of 4. To evaluate a function, it simply means to take your input number and replace x with that value. So if we put in a number 4, we're going to get out another number. And the way we find that number is by taking the rule, which is 3 times x squared plus 2 times x minus 1, and evaluating it. And now here we have to be careful. Remember, from your order of operations, when you evaluate this, the first thing you do is the exponent. So in other words, we would have 3 times 4 squared, in other words, 3 times 16, plus 2 times 4, which is 8, minus 1, or in other words, 48 plus 8 minus 1. And if we combine these all together, we get an answer of 55. So notice that when we put in a number, our output is also a number. In this next example, we're going to be putting in an algebraic expression. And when we put in an algebraic expression, our output is also going to be an algebraic expression. So we're going to have 3 times a plus 2 squared plus 2 times a plus 2 minus 1. Now here's another place where we have to remember our algebra. So to take a plus 2 squared, we don't simply square a and square 2. Instead, if we take a moment to work that out, a plus 2 times a plus 2. Now, however you like to do this, some people like to take shortcuts, some people like to distribute, but if we work this out, we'll have a squared plus 2a plus 2a plus 4. In other words, a squared plus 4a plus 4. So notice that if you were just to square a and square 2, we would be forgetting the middle term, which is 4a. So putting that into our expression, we have 3 times a squared plus 4a plus 4. We'll go ahead and distribute here, plus 2a plus 4 minus 1. And now let's go ahead and distribute here. So we're going to have 3a squared plus 12a plus 12 plus 2a plus 4 minus 1. And if we simplify by combining our similar terms, we have 3a squared plus 14a plus 15. So if we put in an algebraic expression of a plus 2, our answer is also an algebraic expression involving a. Given the function f of x is equal to 3x squared plus 2x minus 1, find f of a plus h minus f of a over h. This expression here is a very important one, and it's called a difference quotient. And it's going to be very important and key to your success in the first chapters of algebra. So we want to make sure that we have some opportunity to practice it in this class that's getting ready to take algebra. All right, so just like before, wherever we see the input value x, we're going to replace it first with a plus h, then with a, and simplify. So let's start with f of a plus h. Now there's going to be a lot of algebra going on, so I'm going to take this in several pieces. First, let's just evaluate f of a plus h. Well, that's going to be 3 times a plus h squared plus 2 times a plus h minus 1. And just like before, this a plus h squared, we have to be careful when we do that, all right? So if we take a plus h squared, in other words, a plus h times a plus h, when we multiply, we're going to get a squared plus ah. And again, we're going to get another ah plus h squared. We'll have 2 of these. So that's going to give us a squared plus 2ah plus h squared. And so let's go ahead and put that into this expression that we're simplifying. So we have 3 times a squared plus 2ah plus h squared. We'll distribute here, plus 2a plus 2h minus 1. And finally, we'll distribute here and gather our similar terms. 3a squared plus 6ah plus 3h squared plus 2a plus 2h minus 1. And if we look at this, there are no similar terms to combine, and so f of a plus h is this long expression right here. And that's just the first piece of the difference quotient. Now, the second piece simply says to replace x with a. And so that's easy to do. There's no algebra to simplify there. And so let's go ahead and start simplifying the difference quotient. So f of a plus h is this long expression which we just figured out. 3a squared plus 6ah plus 3h squared plus 2a plus 2h minus 1. Now we're going to subtract a plus h, and it's, f of a, and it's important to remember to put parentheses around it. So we're going to have 3a squared plus 2a minus 1. And the reason the parentheses are important is because we're going to need to remember to distribute that negative sign. And then in the difference quotient, this is all going to be divided by h. So now it's just a matter of simplifying. Now notice that when we distribute this negative sign, here we have a positive 3a squared, and we're going to have a negative 3a squared. Those are going to cancel. Here we have a positive 2a, and when we distribute this negative sign, we're going to have a negative 2a, so these terms are going to cancel. And finally, here we have a negative 1, and here we have distributing a negative times negative 1, that'll be a positive 1. These are going to cancel. And so what's going to be left in the numerator is 6ah plus 3h squared plus 2h, all divided by h. Now there's one final last step. Notice that all of the terms in the numerator involve an h. That's a common factor. So we're going to factor that out, which is going to give us h times 6a plus 3h plus 2, all divided by h. And we know that h over h is equal to 1. And so after all of that, our final answer is 6a plus 3h plus 2. And that's an example of a difference quotient. Again, something that's going to be very important as you start your study of calculus.